See here, in the previous two sessions, we clearly discussed about what is recursion, and we have seen some example programs like finding factorial using recursion, and uh, finding GCD of two numbers, finding sum of digits, finding power values, and printing Fibonacci series using recursion. So we have seen these programs. In today's session, I want to talk about variants of recursion. So topic name is variants of recursion. So variants means types. Okay, so what is the topic name? Types of recursion. Okay, in our syllabus book, he has given that variants of recursion. So topic name is variants of recursion. Okay, so based on the functionality, based on the behavior, this recursion can be divided in many ways. Like single recursion and multiple recursion. Single recursion and multiple recursion. Okay, so based on the number of recursion calls, we are dividing recursion into two types: single recursion, multiple recursion. Like that, direct recursion and indirect. This is another category. Direct recursion and indirect recursion. Based on the direct calling or indirect calling, we are dividing into two types: direct, indirect. Okay, so tree recursion and linear recursion. Tree recursion and linear recursion. Okay, based on the growing behavior, we are dividing this like tree recursion and linear recursion. Okay, so like this, tail recursion and non-tail recursion. Tail recursion and non-tail recursion. Okay, based on the end operation, we are dividing recursion into two types: tail recursion and non-tail recursion. So based on the number of times a function called within the same function, we are dividing into two types: single recursion and multiple recursion. Okay, based on the direct call and indirect call behavior, we are dividing recursion into two types: direct recursion and indirect recursion. Okay, based on the growing characteristic, we are dividing the recursion into two types: tree recursion and linear recursion. Based on the ending operation, tail means end. Based on the ending operation, we are dividing the recursion into two types: tail recursion and non-tail recursion. Then what is single recursion and what is multiple recursion? Listen carefully here. You already know it. Very simple. Nothing is there. See, already we have seen example programs on recursion. We have seen number of example programs on recursion. So which one comes under which category? That part I will explain in today's session. So single recursion means if a function is called within the same function for one time. If a function is called within the same function, if a function is called within the same function, if a function is called within the same function for one time, then that is called single recursion. So best example for it is finding factorial of the number. In the previous session, we have written a program to find factorial of the number. Okay, see, to find factorial of the number using recursion. So that program, just a minute, recursion. Yes, this is the code. This is the code. In the previous session, for our class only, I have typed it. Okay, in the previous session, I have written this logic. See, I'm pasting here. Observe factorial. Finding factorial of the number using recursion. So here, we are calling fact function here within the fact function only. Here we are calling the fact function within the fact function only. So in the fact function, I'm calling this fact function for how many times? One time. So if we are calling a function within the same function for one time, that is called a single recursion. Single recursion. Okay, I explained power program. Power, finding power value using recursion. So that is also example for single recursion only. We're calling power function within the power function for how many times? One time only. Okay. And we have seen GCD program. In the GCD program, in the finding GCD using recursion. So we are calling this GCD function for how many times here? One time only. So GCD function we are calling within the GCD function for one time only. So if you here some function, sum of digits we are finding. So sum function we are calling within the sum function. So finding sum of digits, finding GCD, finding power, finding factorial. All these are examples of single recursion. Then what is the example of multiple recursion? Okay, printing Fibonacci series I explained. In the previous sessions, I covered how can we print the Fibonacci series. That is one is example for multiple recursion. So if a function is called within the same function, if a function is called within the same function for two or more times, for two or more times. If a function is called within the same function for two or more times, means multiple times. If a function is called within the same function for multiple times, and that is called multiple recursion. Then which one is the example? Finding Fibonacci series, printing Fibonacci series is the example for it. So to print the Fibonacci series, this one is the logic. Here we are printing Fibonacci series. See here, see here, observe, I'm pasting here. So here we are printing Fibonacci series using this function. Here we are calling Fibo function for how many times? Fibo function we are calling, this Fibo function we are calling within the Fibo function only. This Fibo function we are calling within the Fibo function only for how many times? Two times. Fibo of n minus 1, Fibo of n minus 2. So two times we are calling here. So Fibo function we are calling within the Fibo of function, within the Fibo function for how many times? Two times. Fib of n minus 1, first time we are calling. Fib of n minus 2, again we are calling. So here we are calling Fibo function for two times within the Fibo function only. So if a function is called within the same function for two or more times, that's called multiple recursion. Or you can say this as binary recursion. Binary means two. Two times we are calling. Or you can say this as n-ary recursion. N-ary recursion. Okay. So sometimes when we want to find permutations and combinations, when we are working with permutations and combinations, so many times we have to call recursively. So at that time, more than two times we may call. If we call more than two times, I'm calling that as n-ary. If we are calling a function within the same function for two times, I'm calling that as binary. If a function is called within the same function more than two times, I'm calling that as a n-ary. So that may be binary or n-ary. Simply you can say multiple recursion. So that's why I'm calling multiple recursion can be also called as binary recursion or n-ary recursion. So in case of permutations and combinations, to solve permutations and combinations problems, we use n-ary recursion. To print Fibonacci series, we are using binary recursion. So this is about multiple recursion. So single recursion means if a function is called, this function is called within the same function for how many times? One time. If a function is called within the same function for one time, that is single recursion. Multiple recursion means if a function is called within the same function for multiple times. Here we are calling Fibo function. We are calling this Fibo function for two times. That is multiple recursion. That's it. Next. So this is about single recursion and multiple recursion. Next one is what? Direct recursion and indirect recursion. Okay. Based on the direct or indirect call, we can divide the recursion into two types. Okay. So what are those? Direct recursion and indirect recursion. So direct recursion means the name itself is indicating the meaning. Direct recursion means if a function is called within the same function directly. If a function is called within the same function. If a function is called within the same function, if a function is called within the same function directly, then it is called direct recursion. Then it is called direct recursion. So if a function is called within the same function directly, that's called direct recursion. Okay, so best example for it is finding factorial. Same, finding factorial example I'm taking. So here we are calling fact function within the fact function only. For one time we are calling. Okay, so we are calling fact function within the fact function directly. So directly we are calling. So directly we are calling fact function within the fact function. So it is called a direct recursion. So here we are calling the fact function within the fact function directly. So if a function is called within the same function directly, that's called direct recursion. So all the previous sessions example programs are direct recursion only. Till now we didn't write any program on indirect recursion. Okay, then what is indirect recursion? So indirect recursion means, okay, we call a function, that function calls this calling function, that is called indirect. For example, here a function is there, a function is there, and b function is there. A function is there and b function is there. For example, I'm calling a function within the a function. This is what? Direct recursion. I'm calling a function within the a function. So if we call a function within the a function, that is called direct recursion. But what I'm doing is, from the a function, I'm calling b function, and this b function is calling a function indirect. So instead of calling a function directly, what I'm doing is, from the a function, I'm calling b function, and this b function calls a function. This is called indirect recursion. Okay. So if a function is called another function, and that another function calls this calling function again, that is called indirect recursion. So indirect recursion means if a function is called another function, if a function is called another function, if a function is called another function, and another function, that another function, and that another function, that function, and that another function, that another function calls this calling function, then it is called, then it is called indirect, then it is called indirect recursion. Indirect recursion. Okay, so here we are calling a function. Okay, so we are calling not same function, we are calling another function, that another function calls this calling function. So from the a function we are calling b function, so this b function calls this a function again, that is indirect. Okay, so I'm writing one example on indirect recursion. Observe. So same fact real I want to find out now. Observe carefully. So instead of calling fact function, I'm calling another function here. Here I'm calling another function. Okay, I'm taking that function name as f1. So what is the function name? Function name is f1. Okay, so that f1 function I'm defining here. F1 function I'm defining. Okay, so it is passing n minus 1 value, integer value. I want to capture that n minus 1 value. So write int n. So instead of calling fact function, I'm calling another function f1 here. F1 is the function name. Okay, so we are calling f1 function here. This f1 function calls that fact function again. Okay, so fact of n. So indirectly we are calling. So instead of calling this a fact function within the fact function, from the fact function I'm calling another function f1. This another function calls this calling function fact. Indirect. Okay, so this is called indirect recursion. Observe here. Here we are calling f1 function, and this f1 function is calling this. We are calling f1 function from the fact function. So fact is the calling function, f1 is the called function. So from the f1 function, I'm calling the calling function again. This one is called indirect recursion. Okay. So indirect recursion means function calls another function, that another function calls this calling function again. That is indirect recursion. Okay. So let me show it practically. Observe carefully here. I'm copying it. I'm opening developer C++. Uh, just a minute. I'm opening new source file here. I'm pasting here. Okay. Now from the main function, call it. From the main function, call the fact function. So I want to find fact of 4. So write fact of 4. Fact of 4. I want to print that value that returns the value. So I want to print that value. So see out insertion operator factorial equals to then insertion operator fact of 4. So 4 factorial we are finding. Okay. So here we are calling fact function. Now what is the n value now? N value is 4. Now n value is 4. Okay, so here checks the condition 4 equals to 1. Condition false, so it comes to the else block. So in the else block, this value will become 4 into okay, f1 of n minus 1. So f1 of n minus 1 means n value is 4, means 3. So now this 3 value will be passed to the, we are calling which function now? We are calling, here we are calling f1 function. So this f1 function will be called, it passes this 3 value to the f1 function. So now what is the n value now? N value is, now n value is 3. N value is 3. N value is 3. So fact of 3. Now it calls the fact function again. Now here it calls the fact function again. It calls a fact function. So we are calling f1 function from the fact function, and f1 function is calling fact function again, but it is passing value as 3 now. So now what is n value? Now n value is 3. Now n value is not 4. Now n value is 3. Okay. So like this value, this condition will become false again. That comes to the else. So like this, fact function calls f1 function. F1 function again calls fact function. So this is called indirect recursion. Okay. Now let me execute this program. Observe. So here in the fact function, we are calling f1 function. So declare the f1 function here. Declare the f1 function. So hash include IO stream using namespace std, declare the function f1 function. F1 of return type is what? Argument type is what? Int. Okay. So now I'm running the program. Observe. I'm saving it in our folder cppds coed. I'm saving it with the name, okay, factorial fact.cpp. I'm saving it. Now observe the output. Okay. So F1 was not declared. F1 was not declared. So what I'm doing is I'm writing return type as int. Now observe. So what it is printing? Factorial equals to 24. Observe carefully here. Here I didn't write return type here. If we don't write return type, implicitly that takes return type as int only. If we don't write return type, for every function in the C++ or in the C language, return type is by default int only. So return type for every function is int only. So that's why I didn't write here. No problem. Even if you write, no problem at all. But I'm not writing any return statement. Observe here. Okay, not required in this situation. But don't take void here. If you take void, that will not evaluate this expression. If you take void here, that will give error. This function is not returning any value. So I'm writing void here. So if you write void, that will not evaluate the expression. It is giving the error. Okay, operands of types int and void to binary operator. So here we are using binary operator into. Okay, so this n is the integer value. This f1 return type is what now? Wide. So wide value you cannot multiply with the int value. You can multiply int and int. You can multiply float and float, but you cannot multiply int and wide. So that's why in this example, you must take return type as int only. Remember this. Okay, even if you are not writing return statement, no problem. Okay, implicitly that compiler takes return statement. No problem at all. Okay, even if you don't write int also, no problem. Default return type is int only for every function. Okay. Now observe. Just a minute. Ambiguity. Sorry. Here wide is there. In the declaration we have to modify. In the declaration int. Okay. Yes. Observe. Factorial equals to 24. Okay. I hope you understood. This is indirect recursion. The point to understand here is, okay, we are not calling this fact function directly here. Here we are calling fact function indirectly. From the fact function, we are calling f1 function, and this f1 function is calling that fact function. This is called indirect recursion. Okay. Then next category. Next category is direct indirect is over. Single multiple is over. Direct indirect is over. Next one is what? Tree recursion and linear recursion. Listen carefully. Pay attention and listen carefully here. So tree recursion. If the recursion grows like tree, that is called tree recursion. Okay. If recursion grows, okay, if recursion is growing, okay, if recursion is growing, okay, if the recursion has growing characteristic, if recursion is growing, then it is called tree recursion. Then it is called tree recursion. So here growing property will be there. Based on the growing property, they divided into tree recursion and linear recursion. First, see about tree recursion. So if the recursion is growing like tree, then that is called tree recursion. Okay. So in this, observe carefully. After completion of recursion, if pending recursive calls are there, if recursive calls are there after completion of recursion evaluation, if recursive calls are there, in set of operations, then that is called tree recursion. So after completion of recursion also, if recursive calls are there, then it is called a tree recursion. Okay, observe carefully. So after completion of recursion evaluation, if recursive calls are there in the set of operations, we call that as the tree recursion. Best example for it is finding Fibonacci series. So to find the Fibonacci series, what is the logic? To print the Fibonacci, printing Fibonacci series is the example for tree recursion. So printing Fibonacci series using recursion. This is the example for tree recursion. This is the example for tree recursion. Observe here. For example, from the main, I'm calling like this. I'm calling like Fibo of 4. I'm calling Fibo of 4. Okay. So if we call Fibo of 4, this Fibo of 4 will become 4. Means any value is 4. So not 0, not 1. It comes to the else part. So this is 4 minus 1. Means this Fibo of 4 will become, this, observe carefully. This Fibo of 4 will become, just a minute. Please wait. Yes. Observe. Observe carefully here. See. This Fibo of 4 becomes, Fibo of n minus 1. N value is what? 4 now. 4 minus 1 means Fibo of 3. Okay. And Fibo of n minus 2. Fib of 4 minus 2. N value is 4 now. 4 minus 2 value is 2. So fib of 3, fib of 2. Okay. So we are calling fibo function from here and from here. So first fibo 2 will be called. Fibo 2. So we are calling fibo function within the fibo function only. So fibo 2 will be called. So now n value is 2. So again this value will become, this recursion will be evaluated now. Fibo of 2. So fibo of 2 will become fibo of 2 minus 1. Fibo of 2 minus 1 value is what? Fibo of 2 minus 1. Next fibo of 2 minus 2 means fibo of 0. Okay, so we already know fibo of 0 value, n value 0 means that returns 0. Fibo of 1 means n value is 1, so that returns 1, 1. So here recursion is evaluated. After completion of recursion also, another recursive call is there. Observe fibo of 3, another recursive call is there. So till here, right side recursive call, evaluation is over, but left side recursive call is there. Observe here. Okay, after completion of recursion also, if recursive calls are there in the set of operations, that is called tree recursion. Now this is called tree recursion. So it is growing like tree. Observe, it has growing property. Okay, now this fibo of 3 will become fibo of 3 minus 1 and fibo of 3 minus 2. So this fibo of 3 will become fibo of 2 and fibo of 1. Fibo of 1. Then fibo of 1 will be evaluated. This fibo of 1 value will become 1. Then fibo of 2 will be evaluated. Okay. Then fibo of 2 value will become fibo of 2 minus 1 and 2 minus 2. Means fibo of 1, fibo of 0. Okay. So this one will become, just a minute. This one will become fibo of 2 minus 1 means 1. Then fibo of 2 minus 2 means fibo of 0. So it is growing like a tree. So that's why it is called a tree recursion. Okay. Then next one is linear recursion. So what is linear recursion? Linear recursion means it will not grow like tree. It will not grow like tree. Okay. So if the recursion has no growing property, that is called linear. Okay. After completion of recursion, after completion of recursion evaluation, after completion of recursion, okay, no recursive calls will be there. Okay, after completion of recursion, no recursive calls are there. If no recursive calls are there, no recursive calls will be there. So after completion of recursion, if no recursive calls will be there, that is called linear recursion. So best example for it is finding factorial. Finding factorial. Finding factorial. Observe. So when we find the factorial of a number, so what is the logic? This one is the logic. I'm copying. This is a function, a recursive function. Observe here. I'm pasting here. So we are calling like this. Fact of 3 we are calling. So this fact of 3 will become 3 into fact of 3 minus 1 means 2. Okay, n minus 1. N value is what now? 3. So 3 equals to 1. Condition false. It evaluates this one. It executes this one. So 3 into fact of 2. So this fact of 2 value will become 2 into fact of 1. Fact of 1. Okay. This fact of 1 value will become 1 now. In front of that 2 is there and in front of that 3 is there. So now it calculates it. Expression evaluation. So here after completion of recursion, there is no pending recursive calls. After fact of 1, it is performing the expression calculation here. After completion of recursion, there is no other recursive calls. After completion of recursion, if there is no recursive calls, that's called a linear recursion. After completion of recursion, if pending recursive calls are there, that's called a tree recursion. Okay, in the Fibonacci series, after evaluating this Fib of 2, also Fib of 3, pending operation is there. After completion of recursion, recursive calls are there. Whereas in this case, in the linear recursion, after completion of recursion, okay, there are no pending recursive calls are there. Directly it is evaluating the expression. It is calculating. Okay, so now you can say this as the linear. After completion of recursion, if no recursive calls are there, that is linear. After completion of recursion evaluation, if recursive calls are there, that is called tree recursion. That's it. Next type is tail and a non-tail. Tail recursion and a non-tail recursion. Listen carefully. Listen carefully here. So only 3 minutes time is there. Listen carefully. Tail recursion means, tail means what? End. Okay. If recursive call is the end operation, tail recursion. If recursive call is the end operation. If recursive call is the end operation, if recursive call is the end means what? Tail, or you can say end. If recursive call is the end operation, then it is called tail operation, tail recursion. Then it is called tail recursion. If recursive call is the end operation, then it is called tail recursion. Okay, best example for it is finding GCD. Finding GCD is example. Finding GCD of two numbers. Finding GCD of two numbers is the example for this tail operation. Observe carefully here. Already we have written this code in the previous session. I'm copying that one. Okay, so finding GCD. So this one is the observe. Now, finding GCD is example for tail recursion. So this is example for tail recursion. Okay, non-tail recursion. For non-tail recursion, example is non-tail recursion means recursive call is not final operation. In this, if recursive call is not final operation, if recursive call is not final operation, then that is called non-tail. Best example for it is finding factorial. Observe carefully here. Just now I explained it. Okay, so after finding the factorial, so after evaluating the factorial, so that is evaluating here, fact of 3. Observe carefully. Just a minute. So see here. Here I'm passing n value as 3. N value as 3. Okay, that becomes 3 into fact of 2, then 2 into fact of 1, that value will become 1. So here recursion is over. After recursion, that is performing what? After recursion, that is performing expression calculation. Okay, that is calculating 3 into 2 into 1 here. So fact of 1 means recursive call is over. After completion of recursive call, it is performing what? It is performing another operation, calculating the expression. So calculating the expression is the last operation. So it is non-tail operation. Recursive call is the not final operation. Whereas whenever we are finding the GCD of two numbers, okay, so here we are calling GCD function within the GCD function only. Okay, I am giving number as 12, next number as 15. Okay, so after completion of this call, finally remainder will be 0. So we are y modulus x means 15 we are dividing with the 12. Okay, what is the remainder now? 3. Remainder is 3. Okay, we are calling GCD function here. Okay, so y modulus x value 3. 3 becomes the x value now. Now 3 becomes the x value. Okay, so x becomes the y value. What is the previous x value? Previous x value was 12. So y modulus x means 12 modulus 3. 12 modulus 3. 12 modulus 3. So 12 modulus 3 value is what now? 0. So it returns x value. So now what is the x value? 3. So 3 will be returned. Now observe carefully here. Directly that is returning the result here. So recursive call is the last operation. If recursive call is the last operation, that is called a